In today's video, I'll be going over how I implemented RGB splitting on my web app. I'll be going over all the Lambda code that I wrote and going into some details on what RGB splitting is and how to implement it yourself. So when it comes to my web app, a user can upload an image and I will take that image and process it and return 3 different images. An image with the red values, the green values, and the blue values. And we call this RGB splitting. So in my Lambda code, I process all these images and extract the red, green, and blue channel values. So let's go into the code in order to do that. So here in my infrastructure as code, I defined a Lambda called RGB Splitting Lambda that gets invoked whenever a user uploads an image onto our S3 bucket here, right? So whenever an object gets created, our RGB Splitting Lambda will be invoked. And this is the Lambda code that gets invoked whenever a user uploads an image. So here we have an S3 event that gets passed into our Lambda handler, which is the entry point for our Lambda. And then for each record in that S3 event, we want to process it. And then just to give you a visualization of what an S3 event is, it returns a JSON object of a list of records. Each record will have access to an S3 object, and it'll include the object name, the key, the size, the bucket name, and a lot of the other metadata that gets attached to an S3 event. So here, when we process that record, we pass that record object, and we want to extract the S3 object. We want to get the bucket name, and we also want to get the object key here. So with all the S3 metadata extracted from the object, the first thing we want to do is to get that object from the S3 bucket. And then the next thing that we do is we take that S3 object and we grab the body of it. So the body refers to the actual file that the user uploaded. So we take that file and then we pass it into the Python pillow image object. So we take that image and then we pass it to our create channel images helper method. And here it returns the red, green, and blue images that gets extracted from it, these guys here. And just to give you a visualization of what's going on here. So here I have the image that I uploaded onto my web app. And if you zoom into it, you'll see that I have a bunch of pixels here with an RGB value. So whenever it comes to images and stuff like that, it is composed of a bunch of pixels and a row by column value where each pixel has a red, green, and blue value. And with that red, green, and blue value, you can create a color out of it. So then for our web app, we want to take that original image and then we want to extract only the red values from the image or only the green ones or only the blue ones and give that back to the user. So whenever we want to do RGB splitting, if we want to get the red version of an image, we want to go through all the pixels in that image and zero out the green and the blue values. We only want to have the red values left so then that we can return that version of the image back to the user. And in that case, if you want the green values of the image, we can zero out the red and the blue values for each pixel and just leave the green. So with that in mind, what we want to do is we want to take that original image and create a Numpy array. So what Numpy array does is it takes that original image and returns a 3-dimensional array for us, where each cell or tile within that 2-dimensional array is the pixel values or the RGB values of that image and pixel. So for example, here I have a row by grid column where each tile or each cell is an RGB value. Whatever this visualization is here is essentially what the Numpy array is doing. So then with this Numpy array, what we want to do is zero out the green channel values and the blue channel values from the image. So with this Python and Numpy syntax, what it's doing is for this red image array, right, this 3-dimensional array, we want to grab all the rows, we want to grab all the columns, and then we want to get the first index of the 3rd dimension. So if you're looking at our example here, we want to grab all the rows and you want to get each column in the row, and then we want to get the first index in the 3rd dimension. And that first index corresponds with the green channel values of the image. So we want to take all the green channel values and we want to make it equal to 0. So what this means is we're essentially zeroing out all the green channel values. We're going through every pixel in the image, and then for the green channel values, we're going to zero it out. After we do this Numpy slicing, what we're left with is these values in the array. We have the red values that didn't change. We had the blue values that didn't change, but the first index or the green channel values, it's now equal to 0 for all the pixels. And they want to do the same thing here for the blue channel. So we take that red image array, we grab every row, we grab every column, and then we grab the second index in the 3rd dimension, which is the blue channel values, and we make that equal to 0. So at the end of all this, we've iterated through every pixel in the array, we've zeroed out the green and the blue channel values. So at the end of that, we're left with the red channel values of this image, which is the one right here. So now that you extracted the red channel values from the image, we want to do the same thing for the green and the blue image channel values. Do the same thing, we create a 3-dimensional Numpy array from the original image, and then we zero out the red channel values and we zero out the blue channel channel values. So at the end of all this, we're left with just the green channel values. And every pixel, zero out the red, zero out the blues, and then we're left with just the greens. And then same thing here for the blue. We create a three-dimensional Numpy array. We zero out the red channel values and we zero out the green channel values, and we're left with just the blue ones. And then at the end of this helper method, we return the red, green, and blue versions of the original image. So now with the process images, we want to upload all of this onto S3. So what we're doing here is we're taking the original object key from the image, and then we're pre-printing the color that we've extracted. So for example, if you want to upload the red image, we pre-print the object key with red slash. So at the end of this, in our S3 bucket, we'll have a red directory, a green directory, and a blue directory. So in that way, when our web app needs to fetch the process images, it'll follow this format to get the red, green, and the blue values of the original image. So here we take the pillow image object and then we create a buffer for it. So we use the destination key as the object key that we want to put into the S3 bucket. And in here for the destination bucket, we get that value from our environment variables. So here we're grabbing the environment variable destination bucket from our operating system. And then the way that we set this value is in our infrastructure as code. If you go into our Lambda function, you see here that we've defined an environment variable named destination bucket. And this bucket value is the RGB splitting process bucket. So this makes it so then that if we're deploying our Lambda to our development environment, our gamma environment, or our production environment, we can pass the corresponding bucket name into our Lambda here. So with all that, we've created the put object request for the S3 client, and then we pretty much upload this process image onto our S3 bucket. And then we repeat that process for the red process image, the green one, and the blue one as well. So after the Lambda uploads all the process images onto S3, our web app is now able to grab the images from S3 and display it back to the users. So what I'm going to do now is do a quick demo for you to show you this Lambda code in action, and then go through all the logs in the S3 buckets to show you what I mean by all of this. All right, so here I'm in my web app, and what I'm going to do is upload an image named beachdemoyoutube.jpg. So now if I go into my AWS account and then I go into the buckets and then I go into the user upload bucket, you'll see that I have an image named this as well. So then if I go in my Lambda and I go into monitor, you see that I have a couple of invocations of my Lambda here. So what I'm going to do here now is go into my CloudWatch logs to see if my Lambda got triggered or not. So in my Lambda, I'll log a couple of things such as whenever I receive the event, whenever I process the image, whenever I upload the image, and whenever I load the image into my Lambda here. So now if I go into my logs, you see here that I have done RGB separation completed for beachdemoyoutube.jpg. I've uploaded the image for the red version, the green version, and the blue version as well. So with these logs, we verified that the Lambda ran. So now if I go into my S3 bucket again, and then this time I go into the process bucket, you see here that I have a red, green, and blue directory of all of my images. So then if I go into the red one, and then I see here I have a red / beachdemoyoutube.jpg. And if I click on this and I download it, you'll see that I have the red version of this image here. And if I do the same thing for the green, I have the green version of that image here. And then if I do the same thing for the blue one as well, you see that I have the blue image as well here now. So with that, we verified that once we upload an image onto our web app, we upload it to S3, and then S3 invokes a Lambda that does RGB splitting on our original image, and then it takes those process images and then it uploads it to our process bucket. So with that, I hope you learned something new about RGB splitting and Lambdas and all that stuff, and I'll see you in the next one.